So our next talk is Designing Functional Clothes with Haskell by Noon van der Silk, who is a programmer from Melbourne. He's interested in maths, physics, quantum computing, fashion, art, music, machine learning, dance, and most things. I'm also interested in all those things, so great. He's going to walk us through some of his creative work in using Haskell to actually generate items of clothing. So let's give a big round of applause for Noon.
Yeah, thanks, Mark. Thanks for having me here. Great. So I'm from Melbourne. I run this company called The Brain Shop, and we do deep learning workshops, so kind of teaching people about deep learning. And I guess one could argue I also run this, fashion business. So that's probably what we're going to hear about. I guess I just want to say about this talk, please ask me questions while it's going. I'm going to start off actually with a joke, courtesy of Gala. How much does a t-shirt weigh? Relative? Okay, not bad. Not bad. Any other answers? Okay, the punchline that might make sense later today is a diagram. Thanks, cheers. Feel free to laugh again later as well. But I did have some questions. So who has ever used Haskell here? Some people. Oh, great, cool. Have you had a good time using Haskell? Kind of, maybe, somewhat. Has anyone used the library called diagrams? No, not a single person. Can anyone think of, there's these kind of common myths or jokes that go around about Haskell. Can anyone think of one? There's one in particular that I'd like to debunk today. Monads, yeah, classic Haskell nonsense. Not going to debunk that. But is there another one? The one I'm thinking of from the kind of world of, I think Mark introduced it as at some point as kind of pure functional programming. And the idea is in pure functional programming, you don't have what are called side effects. And I'm here to argue that this t-shirt that I'm wearing is a side effect of a Haskell program that I wrote. So that's another joke. I'll keep pointing them out until I get laughs. But right, so this mate up here with the big grin, he is kind of one of the main people working on Haskell. And the other mate, Brent Yorgi, he's kind of responsible for diagrams. And this is an early meeting of the kind of Haskell working group committee. There's some cool cats in there. So I thought, I guess maybe just because not everyone has seen Haskell before, I'd just do a little bit of a kind of comparison between Haskell and Python. So the main difference, of course, is we have to do, well, we don't have to, but we choose to do type annotations before our function definitions. And the way we annotate our types is probably a little bit strange if you haven't seen it before. But what I've tried to do here is just implement the same function in both Python and Haskell. And has anyone seen this little website, the something encyclopedia of integer sequences? No one has, one person has seen it. Well, dang, you got to check it out because it's awesome. You can just write in any number you like 1, 5, 87, and then it tells you what mathematical function generates that sequence. Super cool. Any questions about this slide? Does the Haskell program make sense? Yeah. So who's seen this fold nonsense before? Anyone? A few people. And so the idea is like, well, I can kind of implement that fold-like thing with just a for loop. Does that make sense? Great. So the observations I wanted to make is that we have to write types. We have a little bit of a different syntax. We have this fold thing. And I guess for what it's worth, even though it's incredibly as they say, unPythonic, you can write that something fun in a Pythonic world. And they use the word reduce as well. That makes sense? Great. Any questions about the differences at this point? Great. Probably just one warning I want to call out is that Haskell people can be obsessed with operators. We tend to use them quite a lot. So one could argue it makes the code more readable. We'll see how we go. So, right. I guess I kind of wanted to start with our plan. And the point here is we want to use functional programming, let's say, to make some clothes. What I'm going to argue is the approach is to kind of take a little Haskell program. Shockingly, I'm going to generate an image. I'm going to upload that image to this website called Print All Over Me. Has anyone heard of this website? What? Oh, amazing. One person has heard of it. Anyone else? Have you used it? Okay. That's exciting, then. Yeah, so this is Print All Over Me. It's super, what would you say, fashionable. And the point is, it has, the one reason I really, really like Print All Over Me over a bunch of other websites that are kind of the same, is that Print All Over Me has heaps of clothing options. So it's got just everything you can dream of and just wacky stuff. So it's really well worth your attention. I'm going to focus the talk on T-shirts, but really the exact same scheme can be applied to anything. And this is what we're going to try and achieve. So this thing here is the Haskell T-shirt. And Print All Over Me can also show it in 3D, which is kind of cool. So any questions about that? Does that idea of the clothing pipeline, Haskell program, image, upload to Print All Over Me make sense? Great. Great, great, great. So, right. So one thing I wanted to kind of, one could argue that what I'm trying to do here is kind of this open source fashion design. And so as a result, I have a little GitHub repo /fashion. And what I do in there is I just paste pictures of stuff that I think is cool, and then I try and recreate it. And this is actually, what would you say? It's kind of like a really important artistic process, if you will, which is that the way I've gotten to use this Haskell diagrams library is simply just by reproducing pictures that I like and then maybe adding my own spin on it. So in particular, the main image that kind of inspired me for this T-shirt here is this black one at the bottom there. You know, it's kind of got this 80s vibe, if you will, triangles and simple shapes. And I guess I just wanted to say, yeah, like really for me, using GitHub to track all this stuff has been super, super cool. And it's probably maybe not even worth mentioning, but it's so handy to be able to paste images from the clipboard into GitHub. I can't even tell you how bad my life would be if I didn't have that ability. So let's do it. Has anyone heard of the Haskell tool called Stack? A couple of people. Yeah. For me, it's really the only reason you can use Haskell these days. It just makes writing Haskell programs very easy, and you know, arguably solves these kind of dependency problems that if maybe you've stayed away from Haskell in the past due to it being a nightmare to install, check out Stack. It's really great. And diagrams in particular is an exceptional library because it has an exceptional manual. That font's a little bit small, but the point of this manual is pictures, code that makes the picture. And every single piece of functionality, every aspect of the library is fully documented with examples in the manual. And I can't tell you how frequently I look stuff up in that manual. here we go. We're going to jump to live hacking. Now, what I kind of want to just show you here a little bit is how my little live coding environment, if you will, for making my little pictures. I've set up a little bit of it in advance, so I'll just show you what's there. So there's not too many files. There's almost all of those files, aside from one, are nonsense related to the package. And you can use what are called stack templates to auto-generate that. And so I've written a little stack template for my fashion little hacking parts. And so what I'm going to do is start up a little kind of watching process. There's going to look at this folder and regenerate a SVG image every time I change it. And this is my code on the right here. Is that font big enough for people to see? Great. So let's make a picture. So the first thing, so this is probably going to seem like a little bit of nonsense, but I just want you to get a feel for what the diagrams library looks like and how quickly you can kind of put something together. So the first thing, so it probably would have been helpful to have that reference picture up, but you remember I'm going to try and make like triangles, circles, squares, and bars is my basic idea. So I'll have a circle, and maybe I'll also have a triangle. Let's see how that works out for me. And then I'll just change this. And what I'm going to want to do is draw those along like this. Which way do you call that? Horizontal, I think, HCAT. My items. Let's see how we go. Yes, circle and triangle. Yeah, hey, thanks. That, I tell you what, is progress. So, one of the probably one of the coolest, so I'm just going to get my little triple of bars here, which I think is kind of neat. And that is just going to be three little, so I'm going to take three of these rectangles that are kind of long and, you know, whatever that word is. And one of the kind of the quirkiest parts about diagrams is this weird kind of application. So you can probably guess what I'm doing there. It's just a little convenience method, a convenience scheme for kind of applying functions. Yes. Any questions about that so far? This is all incredibly obvious, is it? It's all making sense? That's great. That is so good. So, one of the classic, what would you say, styles of the 80s, you know, is going to be a drop shadow. And the reason I like this, the drop shadow function is the first time when writing that we're basically going to take in a diagram and return a diagram. So that's what that little arrow notation is. And so the diagram I'm going to take in is called D. And what I'm going to do is draw D itself, and then next to D, or what that little operator means is literally on top of D, I'm going to draw D again, where I'm going to just move it slightly in the X direction, slightly in the Y direction probably, 0.4. Then, surely, I'm just going to make it black. Okay, so my code compiles. So now, map drop shadow into items. Oh, yeah. Now we're cooking. Maybe I can also make it blue or something. I think I did want to do something like this. Yeah. Eh? Hey? Okay. So, cool, pretty cool. One thing I did, maybe you've noticed if you've looked closely at this t-shirt, is it has the Haskell logo on it. So I'm not going to waste your time with me recalling all the 2D coordinates of the logo, but there they are. whatever. So the point is, and then what I can do, so those are just the XY coordinates of the logo. And then what I do down here is I just turn it into kind of like a solid picture, if you will. So I think that was called Haskell logo. So I can chuck that in here. Oops. In Haskell, we always put our commas there. Right on. So the last thing I want to do here is just chuck in a bit of randomness. So on this shirt, the things are kind of randomly rotated and resized. And so for that, I'm going to take a little function called do transform that's going to take a diagram. And I mean, for the Haskell aficionados, I'm kind of probably committing many crimes against Haskell right now. But nevertheless, I'm going to basically, what I'm returning here is an action that returns a diagram. And the reason it's an action is because I've got to pick random numbers. And random numbers typically come from the environment, such as your computer. So I'm going to take a random scale. I'm going to take a random angle between 360. And I'm going to take a random C that I recall means the color. And then what I'm going to do is the following, which is this. I'm going to return my picture, D, where I apply these things. So I'm going to apply my scale to it. I'm going to rotate it by my angle, and I'm going to color it. And I'm going to be very lazy, and I'm just going to pick out the index C that agrees with my random number that I've picked, and I'm going to turn this LW here means line width. Whatever, probably don't even need that, but that's there. You can get rid of it. I'm going to get rid of it. Oh yeah, great. So we're seeing that my program doesn't compile because I haven't defined those other variables yet. So the classic, you have a little where clause. I'm going to go, well, my colors are going to come from this thing called the Brewer set. Has anyone heard of this thing? No one? It's a shame that you have. Great. Yeah, I have no idea what it is, but what it does is give me cool colors. So that's literally all I care about. So I'm pretty sure I just want that, and then I'm going to want the len of that, which classically is the length of colors minus 1. Let's see if that compiles. Huh, not bad. It does compile. So here we go. So now we're just going to want to run that action over every one of our, what do you call them, items here. So I'll just copy that line just so I don't forget it. But I'm pretty sure my new thing will look something like, I'll call it x's, why not? And I'm going to map m, my do. Who's heard of map? Well, I made you look at reduce before, so hopefully you've heard of map. Has anyone not heard of map? The map function. Raise your hand. Yeah, great, perfect. So if you recall, I'm going to use a whiteboard. So if you recall our for loop, I had fox loop. Our for loop, I had 4x in my list of things, like so, in my Python code, something like that. And then, I had like my total here that I was adding up. And then what I do is just imagine I want to apply a function to each x. Well, I could just apply my function f to each x. And mapping is just basically taking this list, like 0, I've messed up my list, 0, 1, 2, and converting it into 0, f of, f of 0, f of 1, and so on. So just applying a function across a list. Does that make sense? Great. We're map emming because, of course, we're in a monad. That's right. Not in a talk, actually in a monad. And so I'm going to map my do transform across my items. And then if life is good, I'm sure I'm just going to hcat that. True. Not bad. Hit space. All right. I mean, that's it. Like, that's the system working. I think cheers. I think the only thing I've got to chuck in here is the drop shadow. I'm pretty sure I can do that like so. Thank God we got the drop shadow back. Any questions about that? Yes. Solid question, solid question. Yeah, you're not wrong. Also, when I made this shirt, obviously I forgot that I had defaulted the drop shadow to being black. Yeah, it was night. Yeah, that's why, yeah, the lighting person didn't come along and help out. Great. So that's the end of the live hacking. And really what I wanted to kind of show there is the code that we needed. There wasn't heaps of code for that. Hopefully I've convinced you of that. And we got actually something that looks almost exactly like the pattern on the t-shirt. There's the GitHub repo for that, if you want to play around with that yourself. And so, surprise quiz. How many new operators did I use? 15. Not a bad guess. Is that unique operators, or you're counting like the number of times I used the hashtag? Okay, cool. Any other guesses? 3, 2. I think 4. There you go. As promised, lots of operator usage. Where's that? Totally. 5. It's even one I didn't see. That's how ubiquitous it is. Yeah, nice one. Yeah, right. So one thing I wanted to kind of talk about a little bit was the randomness that we use to get the placement of the little pictures looking nice. And this is what happens if you just use more of those random number generators as I used. One could argue it looks a bit not great. So there's a lot of overlap. There's kind of a quirky problem that I can blame on myself, but there's actually like a large region that's kind of doesn't have many diagrams on it. And so I asked my friend Ruben about this, and he told me about these things called low discrepancy sequences. Has anyone heard of these things? No. So the idea really is they're completely deterministic, but they're kind of well distributed. And probably people invented these things for such topics as statistics and machine learning and so on. Basically, all I care about is the random one looks lame and the Halton sequence one looks cool. And and so, well, then I apply that to my little layout thingy, and there you go. I think the Halton sequence one looks nicer. And it turns out that this was just implemented in, it was already implemented in Haskell, so I didn't have to do just any work at all, so it was really great. Great. So this is just a review of what we've seen so far. Are there any questions? Maybe we're having fun, though. Right, so I guess I just wanted to kind of, make an argument that like what we're trying to do here, one could argue is fashion design in code, and think about such questions as, who designed it, Vim or Emacs or Vim or, whoever you want to insult, I think it's pretty clear who designed what here. But, the kind of, when I've been thinking about how to arrange my little kind of open source world around these fashion projects, it's been really interesting for me. Notably because there's just these kind of classic little problems you come up against. Like, well, do I want to put my pictures in my repo, or do I want to store them somewhere else? Do I want to just waste heaps of time by using this Git LFS or something like that? And probably something else that's come up quite a lot for me is like, well, when playing around with different designs, I just want to type stuff and run it. But I also kind of want to be able to remember what I did, and do I want to, should I just copy the file that I'm experimenting with and call it like design v30, v32, or should I just have branches or tags or a really big repo? I did manage to waste a bit of time because I decided that it would be fun. So what I've ended up doing is using a mono repo where I just chuck everything in there. And I commit, occasionally. And what I wanted to do was kind of take that repo, flatten it out across commits, and just look at everything that I've done. So I wrote that pointless tool to do that. Right. So I guess, my kind of like feeling when I've been thinking about this is like, well, I just want to live my life, and just like have fun. I don't want to have all these problems, and I kind of felt like a little bit, suppressed and judged. But actually, as I thought about it a bit more, I realized it's actually reasonably similar, to the reproducibility problems people have in data science and machine learning. With the, I guess the kind of concept of these rendered, data sets that you don't want to include and such. I don't have an answer. It's just an observation. Does anyone have any thoughts on that? Like, what would you do? Would you use a mono repo? Would you kind of have different repos, different branches? Has anyone done this reproducible data science stuff? Does anyone work in that area? One person. Andy, what's your view? We haven't solved it. No doubt, no doubt. Yeah.
It's a huge problem. The other day had to delete gigabytes of generated images and PDFs because I was running out of disk space.
Totally.
And that's just like a huge amount of procedurally generated work that's just gone.
Totally.
And I know it's just possibility space, but yeah, it's an interesting question.
Yeah. Yeah, it'd be great. I'm sure everyone wants that to be solved. So, revisiting one minor, maybe I haven't kind of talked about it too well, but one reason I like the diagrams library is that it easily lets me specify the size of the image that I'm going to output. And that turns out to be relevant when you're trying to print on a certain particular item on print all over me, because the hat has a different dimension to the t-shirt or the pants. And has anyone at all used the turtle library in Haskell? No. I have to say, great choice. It's terrible, but I used it, so whatever. But so all I used that for was basically just having a big list of the different types of clothing I wanted to generate, and then I just ran that, and that generated me, like, let's say 200 images that then, much to Gala's dismay, I manually uploaded to print all over me to make all the designs. Print all over me does have an API, but you have to pay to get it. So I guess I just wanted to show you some cool designs. I should note that these, I didn't come up with the idea of this design. This is just, my process of kind of seeing stuff I like and then remaking it in Haskell and then mucking around with it. So this one on the left, I don't suppose anyone knows where that's from. Your left? And my left. It's the same left. Yeah. Yeah, it's super fun. So I learned cool stuff on that one, like, how to do these like really simple tilings and kind of modifications of images, like kind of iterative modifications. And it's the same idea, like, makes that kind of picture, which is actually just one cell that I, just played around with. So yeah, that was one of these replication things where I learned about repetition and random variations. I'm always trying to be trendy, so me and my colleagues, we bought the website quantumaiblockchain.com. And that, is currently just considering investment. But one other thing it's doing is selling T-shirts. Obviously not successfully, but what I, so I made this picture, and the reason I like it is because it gave me this chance to draw these cool little line diagrams, and you can use names in this library to go like, I want to connect what is up there, the quantum state of $1, to the quantum operator, and so on and so on and so on. And the whole point of this circuit is that you input quantum money and you get out real money. I think that's clear anyway. I didn't really need to explain that. This picture here is one that me and Gala worked on actually. So the kind of the bit of art thing that I was copying is the one on our left there. And the reason I found this picture interesting is actually it's symmetrical, basically. And what you can do, so I only really needed to make the left half of it. And then you may recall what I was trying to show you about the diagrams library was that you can kind of take a picture and then like put a picture next to it that's the exact same picture, if that rambling made sense. The point is this was a cool discovery for me in terms of how easy it was to make this picture once realizing it had this symmetry. And the other cool thing that's kind of happened to me, and I'm sure to everyone with this kind of computational art, is that the accidents you can make also look cool. So you can just do no wrong, at least in my eyes. So that's kind of fun. This one was another one that was just mildly interesting, just in terms of the different application of randomness. So in the middle here, just before the one on the right, is my idea where I was just like, well, I want to have some cool mountains. So what I'm going to do is pick a random number between 0 and 10, let's say, and just draw mountains in that way. Does that make sense? So Gala's idea, in fact, was to start with a random number and then randomly decide on the step whether you go up or down. And you can see Gala's one, who's sitting right there, was the one on the right. And so that looks much better than mine. And that was just reasonably interesting. Any comments on that? Was there a comment? Gala wins, yeah. No doubt. This was just another cool one. So it turns out, if you're into maths, there's a whole world of so-called 2D tilings of the plane, and that's just where you lay out shapes such that they cover, I forget what the definition is, but anyway, squares is probably a tiling, right? So I draw a bunch of squares on the plane as an incredibly boring tiling. But another thing I could do, probably is draw some kind of weird triangle, whatever you call this shape, things. Do you know what I'm trying to get at? So I could draw a bunch of triangles. These are triangles. And whatever this is, it has 5, 6 sides. 4, hexagon. H. You know, and I could proceed in that way. And so then I could kind of generate a plane with no gaps. Does that make sense? Tessellation, someone said. Yeah, great, indeed. Well, there you go. So there's my go at something like that. And the cool thing, as usual, about this diagrams library is that in that, it's a shame the regions aren't kind of more, in this like blue, orangey, whatever, blue, magenta region, I could just stick an entire another diagram. And so you can do that indefinitely. It's pretty cool. Another kind of really powerful idea, actually, was being able to read SVGs as input and then using those paths to draw other diagrams. So that's really, you know, if you will, I kind of think of that as like the power of being able to do programming. Is like, well, I want to create these computational pictures which like look very rigid, if you will, or very, very mathematical. But here's like, well, if I still want to have some kind of artistic human input, well, I can just read SVGs and then use that to do my layout. And actually use that as the background on my BrainShop website. So the contrast isn't great, but basically there's a kind of an emu made out of stars there that I drew on top of the diagram that I made mostly with just nonsense hacking. And I would never be able to draw an emu otherwise, or even still, but there it is. Right. So we're basically at the end. So this is my shop where I've made a few wacky t-shirts. And sorry, I should say by t-shirts, there's also a bunch of other clothing items on there. But there's the Haskell one, which I'm modeling right now. There's there's this evolution of dance one. This one was a bit quirky, but it was kind of something me and Andy actually worked on a little bit to do with using deep learning to watch people dance and then converting that to a t-shirt. This weird AI fashion. Anyway, that's that. Any questions about that? Yo. I do not. No. Well, so what I've got is all the kind of like like the code is all there for most of them in various ways. To recreate that dance one, for example, it'd be, what's the word? You know, elaborate. And likewise with that AI fashion designer one. Yeah, it's a huge failing on my part.
Did you hand select the patterns, or did you sort of automate the generation and upload?
So I have not automated the upload yet. I think if print all over me gives me API access, then I probably would, but I have hand selected the patterns, the kind of like random layout. Frankly, I haven't given too much attention to it, but I've just made sure that, like, for example, the Haskell logo is kind of in a moderately viewable position. No other questions? Great. Well, also my mum wanted me to include a photo of her. She has evidently referred to herself as Haskell girl in the garden. You know, wearing one of the other things. So thanks.
Thank you very much. That was really fun. So we've had a few questions through the talk, but does anyone else want to ask a question right now? All right. Oh, you do? Yep, okay. Yeah. Well, I'll just start because I do have a question. So a lot of that was taking images and printing T-shirts, and I guess a way that you would parameterize choosing a T-shirt is really selecting the fit or the neck and the color. Have you looked at other ways of actually doing more pattern-based, like actual fashion design, choosing patterns? And is there a way of sort of automating that? I'd be really interested to hear more on that.
Yeah, I have. I wonder if it's still online, but I have done something like that. So back when, where would it be? silverpond.github.io/AI fashion designer. Imagine if that worked. It does. What if I press F11? And then we wait patiently for the deep learning to load. The point is, this is something I did back when I worked at Silverpond with Andy. You know, what is it? Well, so from Jay earlier, we heard about these GANs that kind of let you walk around in the space of different designs. You know, and Jay was using it to show us different interpretations of certain statue kind of paintings. With any luck, if I click on that, and then I do something like I click here and I do like so. What about like so? I click this. I wait patiently because my computer doesn't have a GPU in it. But one could argue what we're doing right now is AI fashion design, you know, of different clothing items. And surely if I click here, nah, forget it. But it's too slow because my computer doesn't have a GPU. But basically, this is letting me transition from this pant-like thing up here into this kind of top-like thing. Yeah, is that?
Yeah.
Yeah. Cool.
I think I was also wondering if there's a standard for actually generating patterns, so that you can cut out and sew, and whether there's you're familiar with any work in that area of actually generating like wearables that are sort of unique.
Yeah, I have not seen too much in that exact area. So I've seen a little bit of these exact fashion patterns, but generating one of those from scratch and then cutting it, no, that's a dream.
Yeah, because I'd like some of these weird patterns on like a blazer or something,
Totally.
or just like a bizarre cut that just doesn't make sense. I think that'd be really interesting.
Yeah, it'd be awesome.
I just had an idea about your Git problem. Sorry, I was vaguing out
nice.
a bit, when I was vaguing out a bit when you started talking about Git. But there's this lovely thing written in Haskell called Git Annex.
No doubt, yeah.
And it lets you put your binary images into a sort of a separate annex repo, and then you can sort of archive them off and bring them back.
Yeah.
That might be worth looking at.
Yeah, thanks.
Anyone else? All right, I'll just run up there.
This was a more technical question. Did you know Haskell before you went down this little adventure?
I did, yeah, I have to say. Yeah, but I didn't know the diagrams library very well. So, yeah.
Cool.
Anyone else? Last chance for questions? No? Okay, well, let's give another big round of applause for Noom.